In this second example, we have a quadratic function, and we need to use first principles again in order to find the derivative. In this question, we also need to evaluate the derivative when x is minus 2, and that's just going to involve subbing in minus 2 for x in our final answer, and we'll see that towards the end of the question. So let's jump straight into our step-by-step approach. Step 1 is to evaluate f of x plus h. So as we saw in the last example, that just means we take our function and we replace x with x plus h. So in these brackets here, I'll have x plus h. So let me just simplify out that expression. I'll square my bracket first, giving me x squared plus 2xh plus h squared. Then minus 7x minus 7h plus 3. Then I'll multiply that bracket by 2, giving me 2x squared plus 4xh plus 2h squared minus 7x minus 7h plus 3. And as you can see there, that expression can't be simplified any further because we don't have any like terms to add or subtract. Okay, in step 2, we take our result from step 1 and subtract our original function. So this step, I suppose, is just a bit tedious because we need to rewrite this expression we obtained in step 1. So 2x squared plus 4xh plus 2h squared minus 7x minus 7h plus 3. And I'm subtracting my original function, which is 2x squared minus 7x plus 3. And remembering that the minus here just changes the sign of everything inside the bracket. I'm not going to rewrite this whole line just to save time. What I'll do is I'll get rid of the brackets here and just change the sign of everything inside. So that becomes a minus 2x squared. This becomes a plus 7x and then a minus 3 at the end. Now we can check if any terms in this expression cancel. And they do. The 2x squared here at the beginning cancels with the minus 2x squared at the end. The minus 7x here cancels with the plus 7x, and I also have a plus 3 and a minus 3. So what does that leave me with? I have 4xh plus 2h squared minus 7h. Alright, then step 3, we take our results from the previous step as usual, and in this step we divide by h. So I'm taking my 4xh plus 2h squared minus 7h and dividing everything by h. So you can see there's a h in all of the terms in the numerator, so I can divide everything by h then. And that leaves me with 4x plus 2h minus 7. Alright, then step 4 involves taking the limit of the expression we obtained in step 3 as h approaches 0. So we're getting the limit of f of x plus h minus f of x all over h. And what does that mean we do in this step? It just means that wherever we see h, we're going to sub in 0. So we take our result from step 3, 4x plus 2. Okay, now we have a h, so instead of h, we sub in 0 and minus 7 at the end. So what does that leave us with? 4x minus 7. And that is the answer. It is the first derivative of our function with respect to x. Okay, so the very final part of this question is to evaluate this first derivative when x is minus 2. So that means we just sub in minus 2 for x. So 4 by minus 2 minus 7, that is minus 8 minus 7, which is minus 50. And that is the last part of the question. We just used differentiation by first principles to find the first derivative, and then we evaluated a specific derivative at a point.